Hi everyone, welcome back. I'm glad to MC for the next couple of hours. Up next, we have a wonderful presentation on Spring Security called Building Layers of Defense for Your Application using Spring Security Framework. It's action-packed, so make sure to sit in for the whole presentation and the Q&A afterwards because Neha has a lot of information. So up next, be sure to check out Neha Sardana.
Hello and welcome to everyone to Spring One. I'm really sure that you have enjoyed the conference very much. We had so many good topics to talk about with Spring Native, Spring Cloud, and Spring Security as well. I really liked the Josh and his team, how they explained the Spring Security from taxi to takeoff. So that was my takeaway talk actually. So our next presentation is also going to be on Spring Security. So we will talk about the basics of Spring Security. We will talk about the structure, the architecture of the application. And I worked in a bank, so my notion of security is pretty wired in my brain, but it's not really common for everyone to think about security when they're designing your applications. There are a lot of examples on Spring Security. You can find everything on the reference guide as well. But when you think about how to decide which framework to use, do you want to use OpenID, OAuth, or LDAP, or Basic Auth? There are a lot of questions out there. So I'll talk about all these things in my talk. So let's get started. So just a few introduction slide I thought I should add. I'm a software developer. I work at a financial institution at New York. I am also a fellow JUG leader at Garden State Java User Group in New Jersey and New York JavaSec in New York. So we organize monthly events. If you want to get updated about what's happening in the Java world, you should definitely register. I have my Twitter link at the end. My DMs are open, so you can always come back and reach out to me and we will get you registered. I'm also a Spring developer for almost entire my career. I've seen the rise and nurturing of Spring Boot and Spring security frameworks like this. I've been using them for almost entire my software career, and it's pretty exciting to see how mature these frameworks have become, and it's very good. My hobbies are I love to travel, which I'm not able to do due to the pandemic. So I do the other two things. I practice yoga a lot and I watch cricket to just, entertain myself. I have included my GitHub profile. The code that I'm going to share is also there. I'll share the link as well in the presentation later. So you can reach out to me or you can follow me on Medium and Twitter. I also write blogs on open source and how the contributions have helped me become a better developer. So that's about me. Let's talk about the agenda. So we have security, and the security concept cannot be explained without explaining authentication and authorization. These are the building blocks of security, and one doesn't work without the another. So this is important to understand what these concepts are. We'll also talk about the layers of defense you can put up on your web application, like different kinds of defense you should add, just like a castle building approach, one layer over the other. We'll talk about Spring Security, the 5 Ws. So anything and everything on the architecture. In order to have your custom requirement meant for Spring Security, you should know which frameworks, which interfaces are important enough. And I thought that should be included as well. We also have seen some common security threats. Those were covered by Josh's talk yesterday. We will see those as well here, like all the common security threats that are out there and how Spring Security is protecting you against these threats. And these are like by default that it works, and you don't even have to add a lot of things, but you can always customize with Spring Security. That's the greatest benefit of all. We'll touch base on basic authentication, one type of authentication. We'll see JWT, OAuth, and OpenID Connect on the surface as well. We have some code for you as well. And at the end, I wanted to have principles of application security. And this is important for me because I want you to understand the concepts that you should think about whenever you are applying security. You should apply it correctly, because otherwise it's going to be difficult for you to just figure out what went wrong with your application. So basic prerequisites, you should know Java. I hope you know Java. And some basics of Spring Framework, because we will be just touching base on what Spring Framework is. And you are here to learn on Spring One about Spring Framework. So you should know Spring Framework. I'm using Maven as a build tool. You're free to use Gradle as well. There's not much I'll be sharing on Gradle, but I'll be doing the demo with Maven as only. So that's what. So let's talk about what is security. The security comes with authentication first. So authentication is all about validating your credentials. You have your username, your ID or your password. It identifies your identity. So the system will determine if you're saying who you are is actually who you are and nothing else. This is all just about authentication. Then we come to authorization. So authorization is the process to determine whether the authentication user has access to particular resources or not. It verifies your rights to grant you access to resources such as information, database, files, or anything. And authorization usually comes after authentication, which confirms your privileges to perform. So think about authorization like you may be president of India, but you don't have access to files in which presidents of United States has. So there is a difference in you may be able to identify who is the person who's trying to access your resources or your website, but not everyone may have access to all the resources. So you have to really think about who is authorized to do what actions, and it is very important. And these two work together. So if you have good authentication, but you are giving access to all the resources to everyone, that's not going to work, because an unintentional user can update files or delete files or anything like that. So you have to have proper controls. And it works other ways also. Like if you have a good authorizations, you have roles defined, you have grants approved, but you don't have any authentication, then you are allowing everyone to come into your application and have access to it. So that's again not a good idea. So that's why these two work hand in hand. So let's talk about the layers of defense for your application. The first layer of defense that you can put up in your application is your network firewall. The network firewall can help you in many ways. So it will protect your resources, it will protect your servers, it will protect the bombarding or hackers to bombard your applications or your APIs. That's the first line of defense you can add. The second line of defense is your login page. It's a very powerful tool, your login page. You have your user enter your username and password, and you can do all sort of validations on that page itself to restrict the misuse of your resources, your web pages in your application. You can also add security questions. A lot of websites like banking applications, they have security questions added to them. So that's also another use case where you want to have security questions to really make sure that the person who's logging in is the right user. Then another form is multi-factor authentication. Also, like you have an option to have QR codes or a one-time password where you can enter the one-time password and that expires in the next usage. You can only use it once. That's also a form of authentication you can use in your applications. The next one is hashing and salting. So hashing is a mechanism very important for password storing of passwords. You want to create a hash function and you hash your passwords. It is a one-way street, so you cannot get the password back. But there are certain times when you have the same password entered by multiple users, you may have a possibility of getting the same generated hash. So you may want to add a salt to it. A salt will be an additional string, unique additional string that can be added to the hashing function, which will generate a uniquely created hashed password for you, which is also another way to protect your application again. And then at the end, you have authorization. So that's again, once you are authenticated user, you have everything set up, you need to have the proper role or grants to access a resource. Last but not the least, I really like this message. Do not give away any specific error message to the user whenever any of these authentication validations fail, because at times, you are giving too much information to the users. I've seen a lot of websites having, if you enter the wrong password and you have this correct username, it will tell you, okay, this is the wrong password, but it will also tell you that this is the correct username or the user ID, which makes the hacker's life easy, because now they know the user ID is right, and then they will try to hack onto your password. So try to protect your application by having a very generic error messages and not giving away any specific error messages to the user ever. So let's introduce Spring Security Framework now. So what is Spring Security? Spring Security is a powerful, highly customizable authentication access control framework for all your Java applications. It is a de facto standard for securing Spring-based applications. Like all the Spring projects, the real power of Spring Security is found in how easy can be extended to meet custom requirements. And we will see that in a coming few slides, that it becomes, so adding this Spring Security to Spring projects is really simple job. It's not very complex. You can customize it to another level. There are all sort of customizations possible. And I like the fact that they also have samples for each and every possible customization. So you can look at those samples in the repo. I'll also leave some links at the end. And it's always easy to implement the Spring Security frameworks. And that's why I like it. So why use Spring Security? So it has a very easy integration to Spring Boot. So we all are using Spring Boot for many reasons. Managing dependencies better. It is an advanced framework. It has a lot of auto configurations. So Spring Boot is already making our life easier. And now Spring Security with integration with Spring Boot is made it more and more supportable and easy. And it's supported by a large open source community. A lot of projects on Spring Security are open to everyone who can contribute to the open source community. They have their own GitHub page, and you can go and contribute to the library itself, which is very cool. It has an authentication and authorization out of the box. It gives you an easy default access to all these frameworks. So let's say when you're writing a new application and you're not really sure which security mechanism to actually use, you may want to use Spring Security, and it will give you by default all these things, and then you can customize based on your requirements, and your requirements, they may change later on. One again important feature, it is not tied to any particular web server, which is the most important thing. It's very loosely coupled. So it has a filter entry point servlet, and we'll see that in the next slide how the filters and everything work. It has multiple authentication models. We will discuss a few of them in the course, but there are like multiple models like basic auth, OpenID, and OAuth as well. So there's a lot of support, and you can use any authentication models, and it's still improving. Last but not the least, I wanted to talk about how Spring Security protects you from the common security threats. So these things are not very common to all of us, because we are mostly focused on writing our business applications. We are focused on our, writing cool, innovative applications, and we don't really figure out what are the common security threats going on. So we will talk about those as well in details in the next coming slides. So an important feature that due to increased adoption of these frameworks like Spring Security, many of the previously commonly exploits like cross-site request forgery, clickjacking, and many other are no longer on the OWASP list. So OWASP is an open web application security project. It is an open source project, and they gather all the top 10 security threats that are out there. It is contributed by the community. So that's very helpful to know which threats are really, common these days, and it helps community remove those errors and work on that to remove them. So now, how Spring Security integrates? It integrates with web applications. You can integrate with database. There's also an integration with Central Authentication System, SSO. You have OAuth. Again, you can also use an LDAP if you have a authentication mechanism using LDAP, and you can use it with web services as well. So if you have a backend to backend service, you can also use it there. So let's see how to use Spring Security in your application. This is very interesting. So you just have to add this dependency in your form.xml. Since I'm using Maven, you can have your Gradle file, you can add the Gradle file. But this is the only dependency you can get started with. This is something which will add all your defaults and everything to get started. So if you look at this dependency here, you don't have a version ID mentioned here. And that is because your version will be picked up by the Spring Boot project. So that's how you can integrate very easily. You don't have to worry about the versions. And I've worked in software industry well enough to see that it was a nightmare when we had to manage the versions before. So thanks to Spring Boot and Spring Security, it's very, very easy now. So now we will talk about how Spring Security really works. So Spring Security works very simple. It's when you see a client, which is your web browser or any of your applications, they are trying to send a request, let's say an HTTPS request to a server, and this server request is going to your dispatcher servlet. If you don't add Spring Security, the dispatcher servlet gets all your requests with your Spring framework. That's the first entry point. So what we did with adding Spring Security is we delegated it to delegating filter proxy interface, which has a lot of filters in its at the front. So you see, we'll talk about these filters in the next slide, but you see there is a lot of filters who's accessing your request. They are changing your request. They are filtering out any of the bad ones, and you're checking it against all your authentication authorization happens here. So before your request reaches the servlets, it has to pass through many of the filters, and that's very interesting. To enable Spring Security, all you have to do is to register these Spring Security filters, also known as the delegating filter proxy. That's the first line with your servlet container. So delegating filter proxy will forward all your requests to security filter chains, Spring Security filters to perform authentication or authorization checks. The two important things to kickstart your Spring Security framework is your dispatcher servlet and your delegating filter proxy. So dispatcher servlet is already coming from Spring Framework, and then your delegating filter proxy is coming from Spring Security. So this is the expanded version you see. So once it reaches the filter chain proxy, you see there are multiple filters here. So the filter chain proxy's expanded version has a lot of filters, and I have actually 2 slides to show you how many filters it is. It's crazy. It's so many filters. So each filter is doing its one role. So I'll talk about those filters again. So each filter has a role, and it does the role, and it passes on to the other filter to do another role, and then that's how it works. So your application is really going through a lot of these phases before it actually tries to process the request. So look at the filter interface. We see the filter interface is actually coming from the servlet API. It's not part of Spring Framework at all. It has a basic init function, do filter function, and destroy method. So init method is called when a web container is it's called by the web container to indicate the filter is being called into service. The destroy is when it is being taken out of service. The important thing happens is when you are in the do filter method. So if you look at the do filter method, the do filter method has a request, servlet response, and it has a filter chain object. So the filter chain object is passed into this method. It allows the filter to pass on the request and the response to the next entity in the chain. So one filter will know which next filter has to be invoked. So this is a sequence of filters carrying on. So that's why you see one more parameter here. So the next one we want to talk about is the filter chain proxy and security filter chains. So we already saw some examples in the yesterday's talk with security filter chains. And this is what theoretically I want to conceptualize this. So delegating filter proxy delegates your request to filter chain proxy, which in turn delegates to another object, which is security filter chain. So security filter chain is a wrapper around collection of filters that perform actual security tasks. So when your request comes in, your FCP iterates to your SFC in order to find which one it matches with one URL. And I have the next slide, which will show you actually the interface of that as well. So after the above step is done, the appropriate filter is invoked to perform security tasks. So what happens is you may have different URLs for your application, like /user, /admin, or any other URLs. So you can have different security filter chains based on your URL. And with each URL, there comes, it generated a SFC map. So there is another filter chain that gets created, and why the order is important. So you may want to execute the least privileged first. Like I want to execute /admin URL first before I execute /users, if there's any request that should come through or not. So the order of those matters. By default, the order is 100, but you can change the order and on your security configuration files as well. So these are the options you have. So there are options to have multiple SFC in one applications, to have multiple type of authentication as well. So let's say you have /users and /admin. You want to implement /admin with more homegrown authentication. Let's say you want to authenticate and keep your passwords in the database. And let's say you don't want to store user profiles in your database just for security reasons. You can have OAuth authentication. You can authenticate using Facebook or Okta or anything like that. So you have multiple options to do that. And that option is available through your multiple security filter chains. So we'll look at the security filter chain that I talked about. It has a matches method, and then it, based on the request that it matches the URL, it gives you a lot of filters to execute. So each security filter chain will get you multiple filters as well. So this is the method signature talks about. It returns booleans to check if the request matches the filter chain or not, and then it returns the secure list of security filters for the match request. So again, looking at this, each block, we see /foo, star, and then /bar star, or the rest of the request. So each one has their own security filters. A bunch of filters gets executed, and that's how security of your Spring Security works. It's pretty cool. So let's see how the authentication flow works here. So authentication filter creates an authentication request, and the request is passed to your authentication manager. So a manager, what it does, it's very good at delegating things. So it delegates to the authentication provider, and the provider uses the user details service. So this is a class provided by Spring Security. It loads the user details. Again, this is a model created by Spring Security, pretty standard model. And it returns the authenticated principal. So this authenticated principal is very important, because the authentication filter, once it's done authentication, it will set the authentication in the security context. I have a diagram to show you how it works, because anytime you have to find out who the authenticated user is, you can find it out by using the methods in security context holder, get the context, and then find the principal, authentication principal. So that's how it gets. So authentication filter generates a request, and then it authenticates with the manager. Then it goes to the providers. You can have multiple providers here. LDAP provider, you can authenticate with your database. You can use in-memory, which I don't recommend, but it's there for your learning purposes. And then if the authentication is done, it will create the authentication principal and it will add it to the security context in there. So let's talk about authentication object. So authentication object contains principals. The principal is the user. When authenticated with a user and password, it is often an instance of user details. So user details is it's an instance of user details. Then you have credentials, often a password. In many cases, this will be cleared once the user is authenticated to ensure it is not leaked. So you can't just put a debug point and say, okay, which is the password easily. You can actually clear it out. Then you have authorities. So authorities are the granted authorities at a higher level to give you permissions of what users can have access to which resources. There are a few examples like roles and scopes. So you can define the scope of a particular set of URLs, and with specific roles, you can add those scopes in there, and you can assign these authorities to a user so that the user can access which resources, and that's also possible. The authentication object, it looks like something like this. It has get authorities, get credentials, get details. You can also probably get some IP address details here. You can get the principal here, which is the main person who's the authenticated user. And it will tell you if it's an authenticated request or not, because that Boolean will set up to true once the authentication is done and it's stored. And now we look at the authorization flow. So authorization flow is pretty simple than authentication flow. The filter security interceptor will obtain your security metadata by matching the current request. The filter security interceptor will get the current authentication, which is already set. The authentication, the security metadata, and your request is then passed to an access decision manager. And again, when it comes to manager, the manager delegates it to the access decision voters for decisioning. So that will decide, okay, this access to particular URL is available or not. So what happens when there's an exception? So when the access is denied for a current authentication, the exception translation filter delegates to accept access denied handler, and it returns a HTTP 403 status code. That's a standard code for access denied request. So that's why it generates this particular code. When the current authentication is anonymous, the exception translation filter delegates to the authentication entry point to start the authentication process. So that's how it works. So like I said, I wanted to show you a slide on the filter chain ordering. So this is how many filters it has in Spring Security. It has a CSRF filter, it has a logout filter, it has a header writer filter, SAML filter, and CAS filter, and so many. So there are literally 32 filters and out. And in the code sample, I'll show you how many of them gets invoked based on what type of request you have. So you have your things covered here. So now let's see the common security threats. So I took these security threats from the OWASP website, which is the standard website for having the top 10 security threats. The first one is injection. So injection can be anything from a database, NoSQL injection, a SQL injection, or an LDAP injection. So it happens when a user when a hacker or a user is trying to enter a malicious command or a script or a SQL to try to get more information on the database from the backend, or it's exposing your data, by the way. So that's the kind of injection when the interpreter will run these SQL commands. If it hasn't done any checks on what type of data user is entering, then you may end up with your data exposed. We talk about broken authentication. So broken authentication happens when you don't have proper authentication mechanism. Like I said, if you're not properly authenticating, or if you have your authentication set up not nicely, but if you work with the authorization well and you don't set up your authentication well, that may lead to application being hacked. Your identity can be stolen if you don't transport the authentication credentials to the server very well in order to authenticate. That's also a risk of data. You have a sensitive data exposure. So a lot of times you are entering credit card information or your socials on your website, and if that credentials are not handled properly and they are exposed while reaching the server, then again you're risking your application, you're exposing the sensitive data. The XML external entities, they talk about an older version of SOAP. Sometimes you may have an older version of SOAP, and in those XML files, you may expose some external entities which has some credentials into them, and the hackers may hack those entities, and then they can insert some malicious code or maybe query, or maybe they will put a redirect URL somewhere. And that if that's not checked properly, you can have those exposed data as well over there. Then again, broken access control. Like I said, if you are a user of the application and you try to access some URLs which you shouldn't be allowed, you can do, if you don't have a proper access control, you can do a lot of damage on the website. You can do things which an admin should be able to do. That's not what you want to build your application with. Then security misconfiguration. I saw that as an example. Like a lot of times, people see there is a CSRF token which is causing a problem. The application is not running because the application is expecting a CSRF token, and then you just go ahead and just disable the CSRF protection in your security code, and that's not how you should do it. But that's a one way why we should learn about what type of security threats are out there, and you should not misconfigure your security, so you should understand it properly well. Then you have cross-site scripting. So you a user may, again, it comes to when you're trying to enter some data from the user, and the user enters any scripts or an HTML code or anything which can be interpreted by the browser. When your web application is rendered, then it causes a lot of problems because it can execute some scripts which is unintentional. You also have insecure deserialization. So insecure deserialization can actually lead to remote method invocation, which is very harmful. You don't know what the data has changed when it travels from the client side, from your browser to the server. If you don't validate if anything got changed in between, you may end up with denial of service as well. Using components with known vulnerabilities. So always remember, you are adding extra libraries, and those libraries have to be secured as well. So always make sure whenever you are adding third-party libraries, we are all adding third-party libraries for one or other purposes, but you need to make sure that those are not vulnerables, or they are like well-maintained libraries for that reason. And then you have insufficient logging and monitoring. So a lot of times that happens, that you don't have enough logging and you don't know what happened with your application. You don't monitor your logs. You may have good logging, but you don't monitor your logs. So that's again a security problem, because at times, you may have a violation in your application and it will be there in your logs, but there's nobody to monitor it. Or it could be like, if there's nothing on the logs, but there's a violation and the users start complaining to you, and that's really bad to everyone. So let's see how Spring Security protects you against these threats. So everything we talked about is in these headers. So these headers talk about everything. So let's see one by one. It disables the browser cache. So if you see there, max age 0, the first line, this is telling the browser to disable the browser cache. It basically means that the browser is trying to cache the values. If you want to have your custom cache and you want this to be cached, the Spring will back away. But you see, by default, the Spring will try to not cache the URLs or your data in your browser, so that any malicious site, when you access, it's not trying to steal from the cache. It disables the content sniffing as well. So content sniffing, when the browser is trying to guess the content type of the request. So if you have like a script or anything in your tabs somewhere and it's trying to execute those scripts, the browser actually by default, being smart, it will try to identify if it's a JavaScript or anything else, it will disable it. So Spring Security is actually trying to clear these things. So it disables the content sniffing of the browser as well. The most important one is, the next one is the disable frames. It prevents clickjacking. So by default, the Spring Security disables rendering pages within iframes. So iframes are invisible frames. So if you see you're accessing your applications and you don't know what you are clicking on, because it is an invisible frame. So you don't want to click on something you don't know, which you enter your credentials somewhere, you don't know, because it's not visible. So if you're using Spring applications, you are pretty sure that by default, it will disable all the frames and it will prevent clickjacking. That's a very important feature. And that was a very common security threat a few years ago, which is now reduced because of the adoption of Spring Security frameworks. So HTTP strict transport protocol. So a lot of times we don't type HTTPS in the browser because it's a lot of typing words, but at times by default we type HTTP. So what happens is when HTTP goes to HTTPS, if you're using the Spring Security headers, this will by default always follow the HTTPS. That's the max age setup. It follows the strict transport policy. Again, if you are using credit card credentials or your bank credentials or your socials, these things are very important to understand, that they are really handy and they should be implemented. The last but not the least is the reflexive cross-site scripting. So it prevents the browser from rendering a page if it suspects a reflexive cross-site scripting attack. So that's one feature as well. So let's talk about the CSRF protection. So the cross-site request forgery is an attack that forces the user to execute unwanted actions in an application they are currently logged into. So if the user is a normal user, and a successful attack can involve state changing requests like transferring of funds, changing their name or email address as well. So it's literally hacking your identity. So if you have elevated permission and you are caught into a CSRF attack, your entire application can be compromised. So what Spring Security does is it uses a synchronizer token pattern where, along with creation of a session cookie on authentication, it will create a CSRF token which a malicious site cannot use or it cannot access it. And that's why I always mention the CSRF token should not be disabled unless you are using a backend to backend call. So that's where you may not need it, and you're pretty sure about that. But if you're using a web-based application, make sure that you use CSRF token as well. So that's one way to view, because your session can be hacked, but since you're using Spring Security, it will also expect a CSRF token along with your session cookie. So that's another added advantage of using Spring Security. So on the backend side, CSRF filter will expect this token along with the state changing request to allow the request to pass through. So that's always a protection against it. And this is one example for a CSRF configuration for single page application. We saw that in yesterday's talk with Josh and his team. So they implemented using this. This is also telling you that it should only use the HTTPS. So if it that's another added protection that it should use. Then we come to HTTP verb tampering. So HTTP verb tampering is an attack that exploits vulnerabilities in HTTP verb, also known as HTTP method authentication access control mechanism. Many authentication mechanisms only limit access to most common HTTP methods, thus allowing unauthorized users to restricted resources by HTTP methods. And these are like, you may have exposed a URL, let's say a get URL, and a hacker will try to access with a post URL or a delete URL. So you can enforce some of these things by making use of some of the big security beans. You can use strict HTTP firewall policy, and you can add certain methods to be allowed or not. So your firewall will block anything which is not allowed to you. You can also enable the content security policy to prevent the cross-site scripting attacks. Content security policy is an added layer of securities that helps mitigate cross-site scripting and data injection attacks. You can enable this feature. You can configure your app to actually return these headers. You can also use this meta header tag in your HTML page to prevent cross-site scripting. So this is like directing your browser how you should prevent these common security threats. So this is one example that how you can set it up in your. So if you look at this class, this is using web security configurer adapter. It extends this adapter class, and this is where you will all do your security configuration. So right now you see this is configuring. This is using a configure method with HTTP security method. You also have an auth implementation of this as well. And you have to enable web security annotation at the top so that it marks it as your configuration. So this entire class is your one SFC, the security filter chain. And you can have multiple classes, and you can match it with different URLs as well to allow that. So let's look at session fixation. So session fixation attacks are potential risk where it is possible for a malicious attacker to create a session by accessing a site, then persuade another user to log in with the same session by sending them a link containing a session identifier. So somebody is trying to steal your already authenticated session. So what happens with Spring Security, it protects you automatically by creating a new session or otherwise changing the session ID when the user is logged in. So once your user is logged in, your session ID is already used. So it will either create a new one, or it will change the session ID so that the same session cannot be used. That's a pretty cool thing. And again, always use HTTPS in production and never use HTTP URLs. You can configure this using your configuration here. It requires channel. It uses the requires channel. Any request it requires secure. So it will always uh, try to instruct the browser to use HTTPS instead of HTTP. So that's one way to actually implement more secure security of your application. Now let's look at basic auth. So basic auth is pretty simple. Your credentials are transmitted through a header. You have a header name, authentication, and your value comes as basic plus base 64, and you have encoded username :password. And this is for a simple example for basic authentication. So what is the problems here? So the problem is the base 64 encoded is very easy to decode. So once you take out once you hack the header somewhere in your application, everything is easy to decode. You can guess the user's username and password. You also managing password with hashes. If you're using a hash in your password, it is kind of a bottleneck in distributed systems. And the reason why is because you have to manage and store your password somewhere. If you're 100% sure your application is 100% secure, it's not going to happen anything wrong. We cannot never be sure about that, right? So if you are a new application, if you're not really ready for a good security backup for your data of your passwords, then you probably don't want to store everything in your application. So, and then if you're using a third party, then again, sharing username and password for integration with third-party vendor can also cause a lot of problems, because you're giving away your users' passwords and username to some other entity. In case of a distributed application, when you're scaling up, you have to scale up your identity and authentication mechanisms as well. So every time you scale up your applications, your microservices, you have to literally scale up all these details as well. So that's again a bottleneck or a cause of concern. You're exposing so many things in the application, which you don't want to do that. And if you're starting from a monolith application and you're going into microservice, you will require authorization, authentication for each of the service, which will keep on increasing when your applications grow larger and larger. So that's another problem with basic authentication. So let's introduce OAuth 2 and OpenID and JWT and learn about them. So the goal of OAuth 2 was driven mostly because the applications realized that the user password sharing with multiple unknown application was a bigger security threat. So we remember a time when we used to log in into Yelp application with your Google username and password, which was like some time ago, but it was very scary. You don't want to give away your credentials of Google, which has everything, or Facebook, which has everything, to a third-party application. You won't really want to do that. So to allow applications to access the data from third-party apps without the users having to share their password is where the OAuth 2 came in. So problems were while implementing single sign-on as well, because they need to share the password between the applications. So you can't really implement single sign-on as well. So single sign-on also protects you from a lot of times entering your passwords all the time. So that's why. So OAuth 2 came into picture. It's an industry standard protocol for authorization. The OAuth 1 was published in December 2007. It uses the scope to define permissions about actions an authorized user can perform. So OAuth is actually for authorization. It is not an authentication protocol. So you still have to authenticate the user somehow. You have to know who's the user, who's the actual users. And this is coming in the next part, but I wanted to give this URL as well, because everything on OAuth is mentioned on the URL, so you should want to check it out. So now let's come to the other question: how to find out the authenticated user? So that's why OpenID Connect came in. The OpenID Connect OIDC is an extension, is an OAuth 2 extension that provides the user information. It adds an ID token in addition to an access token, as well as /userinfo endpoint that you can get access to additional information from. It also adds an endpoint discovery feature and dynamic client registration. That's all with OpenID. Then we have JSON Web Token, JOT tokens, you also call it. It's a pretty lightweight token. It has all the JSON map information. You can verify it with a digitally signed signatures you have, and those signatures are base64 encoded. It is protocol agnostic, so it can be used as a standalone feature. So all the different type of protocols can be used in a similar way. It has an expiration time. So if your credentials are stolen with basic auth, you are gone. You just lose the access of the application, because once it's exposed, you cannot change anything unless you change your application. But if somebody gets your JSON token, unless you have an expiration time, which is like 100 years ago, 100 years, you can actually restrict your time to like 20 minutes, 2 minutes, whatever you want based on your requirement. But there is a limitation that you should end. And you should always consider having an appropriate expiration time for your JOT tokens. That's important as well. So the structure of JSON is very simple. It has a header, it has a payload, and then it has a signature. So all the information like subject, audience, expiration date, time, issuer of the token, and ID of the token, and the token was issued, where it was issued. All these information is in the payload of the JSON in the JOT token. So example, the token can be used from a mobile application. It gets authenticated with an identity provider. Your identity provider can be LDAP. It generates a user info map. And then based on the map, your access to your resources is provided. So for an example, this is an OAuth 2 authorization code grant. We'll just glance over it because I think it's pretty important to understand. So your user who's a resource owner, because you are the resource, you are actually the owner. The terminology here is a little different because the client is actually your server, your application, where our application is residing. And you create a trust relationship between Facebook. So you're trying to log in using Facebook. So you establish a client ID and a secret. And it took me some time to understand why it was a client ID and a secret, because the client for this is basically your application and not your resource owner or your browser here. So these terms can be confusing at the end. So you're trying to sign in using Facebook, but you have already established a client ID and secret between the authorization server and your client. So your request is forwarded, your auth code is generated, the auth code gets forwarded with the request then to get you access to your resources. So that's how the authorization code grant works. Similar with OIDC, like I told you about the Yelp application, you go to the authorization server, and here it is important because you're providing the scope as well, the open ID and your profile. So we'll see that in the example which I've have for you. I really should have some time for that. So your authorization server will check if you have, it will take consent from your resource owner. That's why you get the pop-up. Do you want to share your profiles and contact details with the application? And then ultimately it redirects back to the your application you are trying to access. So remember, the redirect URL, the client ID, and the secret are most important things here. So let's look at the sample application I have here. So here I'll explain quickly. I have a POM XML. I'm using Java 16. I have all the latest versions of this. I'm using Boot Starter Security. I'm using Spring Starter Web, and I'm also using Okta as an authentication server. So all my issuer URL is being authenticated by Okta. So I've already created a trust relationship between me and Okta, and I've got my client ID and my secret, and I have my authorization URL as well. So that's one thing. The application is pretty simple. I'm trying to get the current user, and I'm not using any database. So that's again a very important thing. I don't want to store any values or any password in my application. It's a very simple application. I'm using method injection to inject the OIDC user, and the model will I'll set up and I'll pass it on to my HTML pages. So that's a pretty simple, straightforward application. Let me try and run it. If you look at the logs here, I've turned the tracing on, and I'll show you how I've turned the tracing on. And I'll try to access my application using a web URL. So let me bring it up to you. Okay, let me do that right away. Let's see. Okay, so I have a local host 8080. And now since I have ID created in Okta, I'll just have to sign in here. And if I sign in here, you'll see I get my name back. So this name is coming directly from Okta. I have not supplied that information. And if you look at the trace logs, you'll see here, there are a lot of filters getting invoked here. Anonymous authentication filter, exception translation filter, OAuth 2 authorization code grant filter. So these are the filters that gets invoked. And we talked about this before. And this is why it is important to understand. And I redirected using the local host 8080. You can redirect using other URLs. So all I had to do is here, if I go in my application properties, I had a issuer, a client ID, and a secret, and I defined a redirect where to redirect the user, and I opened up the trace logs so that you can also see that again. So this was just my application. I'll go back and I'll explain the chat as well. So let me go back to my, yeah, go back to my application. Okay, give me 1 second. Things like this happen sometimes. So we'll come back here again. So let's see. Okay, so now if I have to go back again. So after this code, we should be very clear about what happens. So this is the URL. You can look at the URL and see the try out the sample code. You still have to create an Okta client ID and secret to be used. So you should be able to use that as well. So my final thoughts are pretty simple. You should minimize your attack surface area. Don't give away a lot of features in your web pages, like a lot of search features, which a hacker can use to attack your application. Establish secure defaults. Spring is giving you a lot of secure defaults. You should use them. Try to minimize re-engineering the wheel. Try to use the secure defaults. Then apply the principle of least privileges. So don't give privileges by default. So just give the least minimum privileges when you are trying to give access to your users. Don't give away admin privileges to everyone. That's very important. Then apply principle of defense in depth. So whenever you are writing your application, if you have a UI application backed by a backend application, so don't think like you don't have to apply validations on UI and not validating anything on the server side. Always have an extra line of defense here. Fail securely. So whenever you have a failure in your application, you don't want to give away like your Tomcat server exceptions like I've seen in the past. Don't do that at all. Fail securely, give a valid user or a message to a user. Don't expose a lot of details when you are failing when your authentication or authorization fail. Don't trust services. So this is by default. I say that whenever you add third-party services, do not trust them by default. Do some research when you are adding new frameworks to your application. There are a lot of ways to verify if the application is a secure application. Your GitHub profiles, or if you're using open source libraries, you can always check that on GitHub. Then apply separation of duties. Again, if you have application developer, you should not have access to production, something like that. So you need to separate your duties based on the roles. That's important. Then avoid security by obscurity. Just because you have a /admin URL and you have a username admin and admin, I've seen that in the past. Like, you're not exposing it, you're not telling it anyone. If it's on the internet, it's out there, so don't try to use that. And then keep security simple. It has to be simple. So I wrote an application within the 5 minutes. So that's how simple your security should be. It should not be complex. And then fix security issues correctly. Just like an example, don't disable CSRF tokens just because your application is not working, for example. So make sure that you understand the security issues and you fix them correctly. So That's all I have. There are some references I like. I've also mentioned about OAuth 1 here, which is still in progress, but it's a very good URL that you should definitely want to try out. It's a newer version with less code grants, less policies. It's more secure. So that's what you want to check. So thank you so much. And here's my Twitter handle. You can always reach out to me on Twitter. My DMs are open. So if you have any questions right now, we'll go into the Q&A. But otherwise, we will. You can always reach out anytime you like. So thank you. Thanks a lot. Back to you.
Hi, great presentation. Awesome job, Neha. You really killed it. That's so much information, and for sure, a lot of you might have
I'm on
additional
time.
questions. Definitely right on time. Perfect presentation. To see Neha and to ask her questions personally in a private Zoom call, make sure to check the Zoom link. You should find that in the Slack channel that you can find on the right of your screen. So click on that and you'll find the link to continue to talk to Neha, ask her questions, and she has way more information for sure. She's so smart. Thank you, Neha, for your presentation. In a little
Thank
bit,
you.
we'll have Daniel presenting Steel Toe, which is a .NET framework analogous to Spring, inspired by Spring, and really, really fun to use. Actually, I'll be back in 5 minutes after the break. Thank you, Neha, again. Great job. See you all in 5 minutes.